Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read Lead Success. I've already started with the subject network analysis and control systems. Module 1 is done and module 2, the first chapter, two port networks. In that we have already seen some concepts which are already available in the YouTube. So today in this video we will learn a new topic. We have already seen in module 1 and first chapter two port networks. One port network, there is video already uploaded, admittance parameters and some equivalent networks also it is uploaded. Today we will see impedance parameters, its theory and some concepts and problems. Impedance parameters. Initially we have already seen admittance parameters. Admittance parameters is Y. Impedance parameters is Z in terms of Z. And in many of the videos in module 1 also I mentioned that admittance is the inverse of impedance or impedance is the inverse of admittance, vice versa. Okay. So now we will learn impedance parameters, how to write impedance parameters and its equations like parameters, same like admittance parameters. Let us consider voltage V1 as a response produced by two currents I1 and I2. See, the voltage V1 is a response by two currents I1 and I2. So the equation can be written as Z11 I1 plus Z12 I2 equals to V1. In the same way for V2 is the response for V2 is the response of I1 and I2. So it will be V2 is equals to Z21 I1 plus Z22 I2. And here you can see here the general formula you can write as V equals to V1 V2 and Zi. We know that V equals to IR. R is nothing but impedance. IZ, V equals to IZ. This is a general formula. So only the terms are like V1 is equals to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. So you can write Z11, Z12 and Z21 and Z2 in the matrix form into I1, I2. Same like admittance parameters. We will write impedance parameters also in this way. After that, you can see that the Z parameters are Z11 is equals to V1 by I1 when I2 is 0 and Z12 is equals to V1 by I2. Z12 is equals to V1 by I2 that is when I1 is equals to 0. You should remember here that if you know these equations you can easily write these equations. See, V1 by I1 when I2 is equals to 0. Okay. Z12, you want Z12, we should make Z12 is nothing but V1 by I2 when I1 equals to 0. Okay. Then for Z21, V2 by I1, I2 is equals to 0 when I2 equals to 0. And Z22, V2 by I2 when I1 is equals to 0. In this way you can remember. You should know these equations. The general formula, from general formula you can write these equations by seeing the network. Any of the network we need to reduce into this equations so that we can find the matrix or the Z parameters we can find. Since zero currents results from an open circuit termination, currents is nothing but open circuit termination, the Z parameters are known as open circuit impedance parameters. If you remember, Y parameters or the admittance parameters are called as short circuit admittance parameters. Here they are called as open circuit impedance parameters. Why? Because whenever the current source every time it will be open source and voltage we short it. So short circuit. Okay. Then impedance parameters are easily related to the short circuit admittance parameters. What they are telling is the impedance parameter can be represented in the admittance parameters and vice versa. Admittance parameter into impedance parameters. If you know Y parameters, you can write in Z parameters. If you know Z parameters, you can write Y parameters. using some formulas that we'll discuss in this slide. You know this is the equation from the previous slide. If you apply Cramer's rule, if you want I1, what we need to do? The first column need to be replaced by V1 and V2. That is which is on the left hand side. That is V1 and V2. Z12, Z22, Z11, Z21. This is delta Z by delta Z. Okay. So from this you can get the I1 value, or I1 is equals to what? V1 Z22 by Z11 Z22 minus Z12 Z21. For the next equation, minus Z12 into V2 by Z11 Z22 minus Z21 Z12. In this way you can write. Separately we are making separate equations, like for this separate V1 Z22 by Z11 Z2 by Z12 Z2, then V2 Z12 by Z11 Z22 minus Z12 Z21. Okay, this is V1 terms, this is V2 terms. If you clearly observe, this is in the form of I1 is equals to Y11 V1 plus Y12 V2. From this you can write Y11 is equals to what as Y11 is equals to delta 11 by delta Z. Nothing but delta 11 means what? First row and first column need to be eliminated. Means Z22. Nothing but Z22 by delta Z. This is nothing but Z22 by delta Z. Then you can see Y12. This is Y12, no? Y12 is what? Z12 by delta Z. Z12 by, this is delta Z. Z12 by delta Z is nothing but delta 21. Z12 is what? In this, Z12 is this. So we are eliminating second row and first column. So you will get minus delta 21 by delta Z, that is equals to minus Z12 by delta Z. You need to remember these equations. These are very important for conversions, or else you cannot convert from Z to Y to Z. See, Y11, easy to remember thing is Y to Z if you want to convert. Y11, that is equals to delta 11 by delta Z. Okay, delta 11 is what? We need to eliminate first row and first column. We will get Z22 by delta Z. Y12 means delta 21 by delta Z minus delta 21 by delta Z. Delta 21 means what? We need to eliminate second row, first column. Second row and first column. Nothing but minus Z12 by delta Z. In the same way, we will see Y21. Y21 is minus delta 12 by delta Z, that is equals to first row, second column needs to be removed. First row and second column. Nothing but Z21 by delta Z. Y22 means what? Delta 22 by delta Z. Second row, second column needs to be removed. So you will get Z11 by delta Z. How we are getting this is, see how we have done for using Cramer's rule, how we have took I1. No? In the same way for solving for I2, how it will come? I2 is equals to, we will substitute in the place of second column, we will replace like Z11, this is Z21, and the second column we will replace by V1 and V2. Why? Because we want I2 by delta Z. Delta Z is nothing but what? Z11, Z22 minus Z21, Z12. Okay. These are matrix, using maths formulas. These are, you should know them. This is a small simple table for the conversion. Y in Y parameters is Y11, Y12, Y21, Y22. Y in Z parameters if you want, what is the formula? Z22 by delta Z minus Z12 by delta Z minus Z21 by delta Z, Z11 by delta Z. In the same way, this is Y to Z. If you want Z to Y, you know the Z parameter, that is impedance parameters. Then if you want Y parameters, what we need to do? Same. Y2 to delta Y minus Y1 to delta Y minus Y21 delta Y, Y11 delta Y. Say if you compare these two, they are same. Okay. Just if you want Z parameters, the value if you have if you want Z parameters, If you have y parameters, then you can find this. You can use this for finding z parameters. If you want y parameters, if you have already z parameters with you, then you can use these equations. That's it. Now, if you see here, right side there is a network where Vs source is Z21 by Z11 plus G, ZG. ZG and impedance generator, it is nothing but generator impedance. Then this is a network where resistance, where Z22 minus Z12, Z21 by Z1 plus Z11 plus ZC. If this is the if this is the equation given, so if you want from the Z out, how we can do is, the voltage across V2 is what? Z21 by Z11 plus ZC into Vs plus Z22 minus this. This is the voltage across the this. You will get V2 value. Then the output impedance expressed in terms of Z parameters. Z out is equals to what? This is the Z out. Z22 minus Z21 by Z11 plus ZG. ZG here is nothing but impedance, generator impedance, which we will take as 0. If you take it as zeros, if you take that ZG as 0, then you will get Z11, Z22 minus Z21 by Z11. You know that this is nothing but delta Z. Delta Z by Z11 means what? Delta 22. Z11, when you will get Z11, when you eliminate second row first column. Second row second column, sorry. Second row second column you get Z11. So you can write as delta 22. Delta Z by delta 22 means what? 1 by Y22. Nothing but when ZG is equals to 0, the Z out will be the inverse of admittance parameters Y22. If you inverse Y1 by Y22, you will get Z out. You should remember this. For this special case, the output admittance is identical to Y22. Okay. Now, if each two port has a common reference node for its input and output. See, if it has a common reference node like this, it is a common reference node for its input and output. Then and if the references are connected together as in the figure, then I1 flows through the input ports of the two network in series. See how I1 is flowing? I1 is flowing in series. So it is called as in the series network of two networks. A similar statement holds for I2 also. In the same way, it is moving in a series. Okay. So what they tell is, from this it follows that I is equals to IA is equals to IB. Nothing but, and V is equals to VA plus VB. So VA is nothing but ZA into IA. VB is nothing but ZB into IB. So if you take as IA, IB is equal to I, ZA plus ZB into I is equal to ZI. ZA plus ZB is what? Z. So ZI. Where Z is equals to ZA plus ZB. So that Z11 is equals to Z11A plus Z11B. In the same way, for Z12 is equals to Z12A plus Z12B. Same way for Z21 and Z22 you can write. We will see a problem where convert following Z parameters to Y parameters or vice versa. They have given two questions. They have given Z parameters, we need to convert into Y parameters. Here they have given Y parameters, we need to convert into Z parameters. We will see. We have already seen the formulas in the previous slides. We will see how to convert it now. Initially you take 2, 3, 5, 1 Z parameters. If you want Y parameters, Y11 is equals to what? Delta 11 by delta Z. Delta 11 means what? First row, first column need to be eliminated. That is Z22. Z22 by delta Z. Here Z22 value is what? 1. 1 by depth of this delta Z is 2 into 1 is 2 minus 5 3s are 15. 15. 2 minus 15 is 3. So minus 1 by 3. Then Y12. If you want Y12, my formula is minus delta 21 by delta Z. Delta 21 is second row, first column need to be eliminated. Means the value of 3 is Z minus Z12 by delta Z. That is 3 minus 3 by 2 minus 15 delta Z. 3 by 13 Simons is the unit. Simon is the unit. In y21. Y21 is minus delta 12 by delta z, that is equals to minus z21 by delta z. Minus z21 is which one? 5. 5 is the value. So minus 5 by 2 minus 15, that is 5 by 13 Simon. In the same way, y22 you will get as delta 22. Delta 22 is remove second row, second column. So you will get the z11 value. Z11 by delta z. Z11 is 2. 2 by 2 minus 15. So you will get a 2 by 13 Simon. These are the y parameters. Minus 1 by 13, 3 by 13, 5 by 13, 2 by 13. All are Simons. Unit should be mentioned. Z to y parameters. So y to z we will do now. Y to z how to do? How to do y to z is same way. Z11 is equals to delta 11 by delta y, that is equals to delta 11 means first row, first column will be eliminated, and first row, first column eliminated means the remaining what you get here is y22. So y22 by delta y. Y22 value is 3. 3 by 3 plus 2. 3 by 3 plus 2 is y, because the determinant of y parameters given here is 1 into 3. 3 minus of minus 2. 2 ones are 2, minus 2. Minus 1 into 2 is minus 2. So 3 plus 2 you will get as 5. So 3 by 3 plus 2 you will get 3 by 2 ohms. Then Z12 minus delta 21 by delta y, that is equals to minus 1 by 2 minus y12 by delta y, that is equals to minus 2 by 5 ohms. In the same way, Z21 minus delta 12. Delta 12 is first row, second column need to be eliminated. So you will get the y21 value. Y21 value is minus 1. As the formula also has a minus. Minus of minus is plus. So 1 by 5 ohms. In the same way, Z2. Z2 is nothing but delta 22 by delta y. Delta 22 means what? Second row, second column need to be eliminated. You will get y11 value. That is 1 by 5. So these are the y parameters. Given the set of impedance parameters which is representative of a bipolar junction transistor operating in common emitter configuration, determine the voltage, current and power gains as well as the input and output impedances. The two-port is driven by an ideal source voltage Vs, sinusoidal voltage source Vs in series with a 500 ohm resistor and terminated in a 10 kilo ohm load resistor. See, they have given the Z parameters. They are asking us to find voltage, current and power gains. If you remember in my previous videos, if you have missed that, I have not put the formulas here. Why? Because in the previous video, that is for some equivalent networks, in that I've there are some formulas for voltage gain, current gain, power gain and input impedance and output impedance. So if you missed that, anyway in this also I will show the formulas, but if you miss the topics, you please watch my video which is already uploaded. Now we will continue with the problem. If you see here, first you should write in the form of the parameters. What are the parameters? How to write the equations? V1 is equals to 10 power 3 I1, nothing but Z11 I1. Z12 is 10 I2. V2 is equals to Z21 I1. Z21 is minus 10 power 6 I1. Z22 is 10 power 4 I2. After writing this from question, what they have given is, what they have given here in question, the two-port is driven by an ideal voltage source Vs in series with 500 ohms. They are telling there is a voltage source in series with 500 ohms. So you can write from that question that Vs is equals to 500 I1, resistance into I1 plus with the V1 as the input voltage. You can write. Then and terminated with 10 kilo ohm load resistor. 10 kilo ohm load resistor means we will take that point as V2. V2 is equals to minus 10 power 4. Why? Because at load resistance, if it is like this, plus minus, it will be plus minus. So minus you will consider minus 10 power 4. 10 into 10 power 3. So 10 power 4 I2. So these are the from questions. We need to take those values. After this, you need to substitute these values in the above. How to substitute? Here first you see, you take this equation. From this, I2 is equals to minus V2 by 10 power 4. V2 is equal, then you consider this equation, then put the value of I2 from this equation. Why? Because if you see here also V2 is there, here also V2 is there. If you take the equation in terms of I2 and substitute here, so V2 will be in, you will get the value of V2 from that. So you will take in this way. So 2V2 is equals to minus 10 power 6 I1. I1 is equals to 2V2 10 power 6. Then substitute V1 in equation 3. We will substitute this V1 in equation 3. Substitute V1 means substituting this V1 in equation 3. If you substitute, what you will get? Vs is equals to 500 I1 plus V1 is what? 10 power 3 I1 plus 10 I2. So Vs is equals to what you will get? 1500 I1 plus 10 I2. As you got already I1 value, that is minus 2V2 by 10 power 6. And I2 value also you know, that is minus V2 by 10 power 4. If you substitute them, you will get V2 as minus 250 Vs. Okay. Then substitute I1 and I2 in equation 1 to get V1. Now we got V2. We want now V1. We want V1 and V2. No, then only we can find I1 and I2. So as we need to find current gain, voltage gain, we need V1, V2, I1, I2. So V1, if you want, substitute I1 and I2 in equation 1, then you will get easily V1. If you substitute 10 power 3 I1 and 10 into I2 value, then you will get V1 is equal to 0.75 Vs. Now we are left with I1 and I2. You want I1 and I2. If you want I1 and I2, you already have the equations. I1 is equal to minus 2V2 by 10 power 6. If you substitute the V2 value, you will get I1 is equal to Vs by 2000 and I2 is equals to, you have minus V2 by 10 power 4. So if you substitute V2 value again here, you will get I2 is equals to Vs by 40. Now we got with V1, V2, I1, I2. Now we need to find voltage gains and current gain and power gains. Voltage gain GV is equals to V2 by V1. Formula is V2 by V2. If you substitute V2 and V1 values, you will get minus 333. Then GI, current gain. GI is current gain. I2 by I1. If you substitute values, you will get 50. Power gain. GP. GP is equals to real value of minus 1 by 2 V2 into I2, real value of 1 by 2 V1 into I1. If you substitute, if you see here, these two get cancelled. So V2 into I2 by V1 into I1 minus V2 into I2 by V1 by I1. If you substitute those values, you will get 16670 as the value. Okay, then GP is 16670 approximately. Then Zin value. Zin is equals to V1 by I1. Z input impedance. Zin is nothing but input impedance. Input impedance is V1 by I1. If you substitute those values, you will get 1500 ohms. Then for Z out, output impedance. Z out we have already seen in the previous slides. That is Z out you get by the Z22 minus Z12 into Z21 by Z11 plus Zg. If you substitute all those values, you have all the values. This is Z11, Z12, Z21, Z22. So if you substitute those values in the equation given for the Z out, then you will get as, see if you see here, Z22 is what? 10 power 4 and Z12 is what? Minus 10 power 6. Z21 is 10 and by Z11 value is 10 power 3. Zg value is what they have given in the question, that is 500 ohms, that is generator impedance. So that is equals to, you will get a 16.67 kilo ohms as the output impedance. Find Z for the two port shown in figure. This is very easy. 20, 50, 25, V1 and V2. Okay, first what we need to consider here is apply KVL to the equations. First you consider two mesh currents, that is from plus to minus I1 and from plus to minus I2. If you don't know KVL and KCL, please do watch my video which I have already uploaded in module 1. that is mesh analysis and nodal analysis separately. If you want, you can watch that. Apply KVL to mesh 1 and mesh 2. You will get as V1 minus 20 I1 minus 25 into I1 plus I2. Why? Because current is flowing in the same direction in 25. Both currents. See, this is moving in this is also moving in the same direction. So 25 into I1 plus I2 equals to 0. You will get V1 is equals to 45 I1 plus 25 I2. From this you can see that the equation V1 is equals to Z11 I1 Z12 I2. You got the value of Z11 and Z12. Now we are left with Z21 and Z22. For that we need to apply KVL to the second mesh. Applying KVL to the second mesh, what you will get is V2 minus 50 I2 minus 25 into I2 plus I1, that is equals to 0. If you calculate, you will get V2 is equals to 25 I1 plus 75 I2. So V2 is equals to Z21 I1 plus Z22 I2. If you compare this, Z21 is 25, Z22 is 75. Should know the parameter equations only. I told you need to compare in the form sum. So comparing 1 with A and 2 with B, you will get as Z11 is 45, Z12 is 25, Z21 is 25 and Z22 is 75. So total Z parameters is 45, 25, 5, 25, 75 ohms as the matrix of Z parameters. Next question. Find the Z for the two port shown in figure. If you see here you can consider this as mesh 1 and this as mesh 2 and this as mesh 3. After getting all the three equations, the mesh 3 equation I3 value will be there. Now that I3 value need to be substituted in this first equation and second equation, so that you will get all the equations in terms of I1 and I2. So you can find Z parameters. We will see how. Applying KVL to all the three meshes. First mesh, you will get a V1 minus 40 into I1 minus I3. Why? Because I1 current is moving in this way, I2 current is moving in the opposite way. So you will get as I1 minus I3. I1 minus I3 equals to 0. Then V1 is equals to 40 I1 minus 40 I3. Then apply KVL to mesh 2. This is mesh 2. When mesh 2, then V2 minus 50 I2 minus 25 into I2 plus I3, as they are flowing in the same direction. So what you will get as V2 is equals to 75 I2 plus 25 I3. Now we got. Now here you don't know you don't have any general equation for I3. You have only I1 and I2. So if you want that, then you need to write KVL for the middle mesh, that is third mesh, so that you will get the I3 value. Then you can substitute. For getting that, minus 40 into I3 minus I1 minus 20 into I3 minus 25 into I3 plus I2. Then you will get lastly that 85 minus 85 I3 is equals to 25 I2 minus 40 I1. If you divide these two equations, 25 by 85, 25 by minus 85 minus 40 by 85, you will get the I3 in terms of I1 and I2. Substitute this equation in these two equations. Then you will get in the terms of I1 and I2 only. Then if you see, you will get V1 as 21.17 I1 plus 11.76 I2. V2 is 11.76 I1 plus 67.6 I2. So if you compare with the general parameter equation, then Z11 is 21.17, Z12 is 11.76, Z21 is 11.76, Z22 is 67.6 ohms. You should know here KVL, KCL and the equations, how to, you should remember these equations for the Z parameters. That's it. After that, if you do KVL, KVL thing and compare it with the equations, you will get Z11, Z12, Z21 and Z22. Next question. Find a Z for the two port shown in the figure. Here if you see, there is a 20 ohm, 50 ohm, 25 ohm and there is a dependent voltage source. Voltage dependent voltage source. So what to do? Same way, apply KVL to mesh 1. Consider two currents I1, I2. Apply KVL to mesh 1 and mesh 2. For mesh 1, V1 minus 20 minus 25 into I1 plus I2 minus 0.5 V2. So if you substitute the if you rearrange the things, you will get as V1 is equals to 45I1 plus 25I2 plus 0.5 V2. There is an extra term V2 here. We will see. First you got the equation. Then for the so V2 is equals to V2 minus, for this is the apply KVL to the mesh 2. Mesh 1 is done. Now for mesh 2 it starts here. For mesh 2 apply KVL to mesh 1 and 2. If you apply KVL to mesh 2, you will get as V2 minus 50 I2 minus 25 into I2 plus I1 minus 0.5 V2 is equal to 0. If you rearrange them, you will get the value of V2 in terms of I1 and I2. V2 is equal to 50 I1 plus 150 I2. If you substitute, if you see here that V2 is in the terms of I1 and I2. So this is clear. This is clear. So Z21 and Z2 are clear. Z22 are clear. That is Z21 is 50 and Z22 is 150. If you substitute this V2 in this equation, then again all you will get in the form of I1 and I2 only, no? Then substitute that in the equation 1. So you will get V1 is equal to 45I1 plus 25I2 plus 0.5 into V2 value 50I1 plus 150I2. So you will get as V1 is equals to 70I1 plus 100I2. So Z11 is 70, Z12 is 100. So the Z parameters are 70, 100, 50, 150 ohms. The network of figure is terminated with a 10 ohm resistor across terminals B and D and a 6 milliampere sinusoidal current source operating at 100 Hz in parallel with 50 ohms resistor is connected across terminals AC. Calculate voltage, current and power gains respectively, as well as the input and output impedance if the Z parameters are given. Z parameters are already given. What we need to do is we need to find the voltage gain, current gain and power gain. We'll see that how to do. Initially in question what they have gained. First you write this in the form of the equations. V1 is equals to Z11 I1, 125 I1 plus 25 I2, 25 is Z12, Z21 is 25, Z22 is 75. So V2 is equal to 25 I1 plus 75 I2. After writing this, you should write the circuit in the form of what the question they have given. If you see, it is terminated with 10 ohm resistor across terminals BD. So 10 ohm resistance is connected across terminal BD. After that, what they are telling, there is a 6 milliampere sinusoidal current. This is connected operating at 100 Hz in parallel with 50 ohms. So in parallel with 50 ohms connected across terminals AC. So we have connected according to the question. From this what we can do is, from the diagram you can see that V1 is what? V1 is equals to 6 milli. Current here flowing is 6 milli and here current flowing is I1. So they are in opposite direction. So 6 milli minus I1 into the resistance 50. So V1 across 50 ohms is nothing but V1. Then V2, how we can write? V2 is equals to, this is plus minus if you consider, V2 is equals to minus 10 I2. 10 into resistance into current I2. That's it. From here what we can do? Substitute this Y1 and V2 in equation 1 and 2. Then it will be in terms of I1 and I2. We will see how to do. If you substitute V1 in the equation 1, 6 milli minus I1 into 50 equals to 125 I1 plus 25 I2. Then you will get as 175 I1 plus 25 I2 is equal to 0.3 as first equation. In the same, if you substitute V2 in the second equation, what you will get? 25 I1 plus 85 I2 equals to 0. If using calc, if you find the values of I1 and two unknowns, that is I1 and I2, you will get I1 is equals to 1.8 milliamperes and I2 is equals to minus 0.53 milliamperes. You got now I1 and I2. Here you need to find voltage gain, current gain, power gain. So what you want? V2, I2, V2, V1, I1, I2 you want. Now you got with I1 and I2. We are left with V1 and V2. If you want V1 and V2, what we can do? I1 and I2 values if you substitute in equation 1 and 2, or else it is again a big procedure. Than that, if you substitute this I1 and I2 in the equations V1 and V2, you will easily get. No, see, V1 is equals to 6 milli minus 1.8 milli into I1 is what? 1.8 milli into 50. You will get a 0.21 as V1. Then V2, how you will get? Minus 10 into I2. I2 value anyway, you know, minus 10 into I2 is minus 0.53 milli. You will get V2 is equals to 5.3 millivolts. Voltage gain formula is what? GV is equals to V2 by V1. That is equals to, if you substitute V2 and V1 values, you will get 0.025. Current gain is I2 by I1 minus 0.294. You will get power gain GP is equals to minus V2 by I2 by V1 by V2 I2 by V1 I1. So you will get as G, if you substitute the values, you will get as 7.43 into 10 power minus 3. Then you are left with input impedance and output impedance. If you want input impedance, Zin is equals to V1 by 1. If you substitute, you will get 116.67 ohms. Output impedance, we have already seen that it is delta Z by delta 22. Delta Z is what? 125 into 75 minus 25 into 25. You will get as 8750. And Z1, delta 22 is what? Second row, second column need to be eliminated. That is nothing but Z11 value. You will get as 125. So 8750 by 125 you will get as 70 ohms as the output impedance. In case of Z parameters, you need to follow this formula only. Determine the impedance parameters for the two port exhibited in the figure. They have given a equation network in this way. How to find the impedance parameters? We will see. First, if you see here, this equation, if you see how to write, we will see. You can write in terms, you can write the voltage across this, no? V1 is equals to what? If you consider this as one current, and this here, if I1 is flowing, for example, if here I1 is flowing, if you take, then the current here already flowing is in this way. So what it means? I1 minus the current flowing into this is minus 0.8 V2. Why? Because opposite direction it is flowing through 5 ohms. I1 minus 0.8 V2 into 5. Nothing but I into 5. I into R. V is equals to I into R form it is. So V1 is equals to, I values are I1 minus 0.8 V2 as they are in opposite direction flowing through 5 ohms into 5 ohms. You will write. Then from this you can find that I1 is equals to 0.2 V1 plus 0.8 V2. I1 is equals to Y11 V1 plus Y12 V2. Here, first we are finding, while doing, you got the admittance parameters. After doing the admittance parameters, you can easily convert admittance to impedance parameters. No, we have seen how to convert admittance to impedance and impedance to admittance in the first question only. In the same way, here admittance parameter can be converted into impedance parameters. Initially we have converted into admittance parameters, that is I1 is equal to Y11 V1 plus Y12 V2. Then apply KVL to mesh 2. We'll apply KVL to mesh 2. If you consider this as mesh 2, I2 current is flowing through this, then what you will get? V2 is equals to V2 minus 2I2 minus 0.1 V1, that is equals to 0. You will get I2 in terms of V1 and V2, that is I2 is equal to minus 0.05 V1 plus 0.5 V2. It is in the form of I2 is equal to I21 V1 plus I22 V2. So you got admittance matrix. Admittance matrix we will write first. So from that we can easily convert into impedance parameters. Y is equals to 0.2, 0.8 and minus 0.05, 0.5. You got the values. From this delta y need to find. Delta y determinant is what? 0.2 into 0.5 minus of minus 0.05 into 0.8. Y is equal to 0.14 Simon square. From this you can convert into Z parameters. Why? Because they asked for impedance parameters. How to convert it? Z11 is equals to delta 11 by delta y. First row, first column will be eliminated. You will get as 0.5 by 0.14. You will get as 3.571 ohms. In the same way, Z12 minus delta 21 by delta y. Minus delta 21 means second row, first column needs to be eliminated. You will get the value as 0.8 by 0.14 minus 5.714 ohms. Then Z21 is minus delta 12. First row, second column is to be eliminated. The value is 0.05. As it is minus 0.05, minus of minus it will become plus 0.05 by 0.14. You will get as 0.357 ohms. Then Z22 is equals to delta 22 by delta y. Second row, second column needs to be eliminated. Delta 22 is the minor of the matrix. Delta is nothing but minor of the matrix. So delta 22 is nothing but second row, second column needs to be eliminated. So Y11 is 0.2 by 0.14, that is 1.429 ohms. Simple. From this you can write the Z matrix, that is 3.571 minus 5.714 and 0.357 and 1.429 ohms. Obtain both the impedance and admittance parameters for the two-port network. First, if you see, if you connect this 50 ohms, here also it is same, here also it is same. So I have, for easy purpose, I have changed that to connecting this point, and this also in the same way, 30 ohms with 0.08 V1. From this, if you see, you can easily get admittance parameters by applying KCL. Consider this V1 point and this is a V2 point node, V1 node and V2 node. Apply KCL to node V1. By applying node V1, incoming current is I1, that is equals to, then this is outgoing current, that is 0.02 V2 plus V1 by, this is also outgoing, V1 by 50 plus V1 minus V2 by 100. So this is the KCL. If you don't know how to do KCL, if you want clear way of learning KCL, there is already node analysis uploaded in my YouTube channel. You can please check out. Apply KCL at node 2. In the same way, I2 is the incoming current. Outgoing currents are 0.08 V1 plus V2 by 30 plus V2 minus V1 by 100. So you will get two equations. From this, I1 is equals to 30 milli V1 plus 10 milli V2, and I2 here it is equals to 70 milli V1 plus 43.33 milli V2. From this you can know that this is Y11, this is Y12, this is Y21 and this is Y22. Why? Because these are admittance equations. I1 is equals to Y11 V1 plus Y12 V2. I2 is equals to Y21 V1 plus Y22 V2. So Y is equals to 30, 10 and 70 and 43.33. Total all are in milli sign. Should mention it. Then after this, from this you will find a delta y. Why? Because we need to convert into Z parameters. Why? Because they are asking in for the impedance parameters. If you want, you can first find impedance parameters and then convert to admittance parameters. Anything is fine. Okay, I have converted. It is easy that if you apply directly node analysis, you will get easily y parameters. So you can easily convert Z parameters. So Z11 is equals to delta 11 by delta y. First row, first column, 43.33 by 600 milli. You will get delta y as 600 milli. So 72.21 milli as the milli ohms. Then Z12 is minus delta 21, second row, first column, 10 minus 10 by 600 milli. You will get as 16.7 milli ohms. In the same way, Z21 you will get as formula is minus delta 12 by delta y. First row, second column, you will get as minus 70 milli by 600 milli. So minus 116.7 milli ohms. Z22 is delta 22 by delta y. Delta 22 is second row, second column needs to be eliminated. That is the Y11 value. 30 milli by 600 milli. You will get 50 milli ohms as the answer. You got now Z parameters also. 72.21 minus 16.7 minus 116.7 and 50 milli ohms as the Z parameters. So we have seen many of the problems, even including the dependent sources, independent sources, dependent sources if they have given how to solve and how to apply KCL, KVL in this, and how to find impedance parameters, how to convert impedance to admittance parameters, admittance to impedance parameters, and some of the formulas, and how to calculate voltage gain, power gain. So they ask only these type of questions, so you better solve them, then only you will understand. I have given some 3 questions to solve as a practice questions. These are very easy. This kind of question we have already solved. This kind of question in this video only. If you check, you can easily do this. and this also you need to convert from z to y parameters. It's easy, you can easily solve it. Then this is the answer. This is answer. This is answer. This is z to y parameters. Then they're asking for z to y parameters. This is answer. And then determine the impedance parameters for the series connection. First, by finding z parameters of the individual networks. What we should do is here, apply the find the z parameters of this network separately, and find the z parameters of the the network separately. That is nothing but impedance parameters. After finding, just add the both matrices z1 plus z2. You will get this value. Okay. If you have any doubt, you can please comment in my comment box so that I will go through it. And if you want any extra other sums also, you can just comment me in the comment box. So I will do that video and I'll send. Then we have now done with one port network, admittance parameters, some equivalent networks and impedance parameters. We are left with two topics to complete first chapter of module 2. So with a new topic, I'll upload my next video in the next video later. Now I'm stopping the video here. Thank you. From Sri Sai Tech Edu YouTube channel, Read, Lead, Success. Keep reading.